This is the homework helper for Chapter 4, Section 6 in the 7th grade workbook, Metric Measurements. So in the top part here, we're supposed to choose the most appropriate metric unit for each measurement, and we're supposed to justify our answer. So as you saw in the notes presentation today, that information is in your textbook on page 236. And what it gives us there is a list of metric measurements and what their benchmark is, something that we can equate them to that we would understand. Remember, if we're talking about the metric system, we're talking about things that have meter in them, or things that have liter in them, or things that have gram in them. If they don't have one of those three things in it, it's not something we can consider. So if we look at number 1, we're talking about the capacity of a paper cup. Well, if we're talking about capacity, we're talking about liters. So the three they give us to look at are a milliliter, which is how much you can fit in an eyedropper, a liter, which is the amount of water in a large water bottle, or a kiloliter, which is the capacity of 2 large refrigerators. So, since a liter by itself would fill a full water bottle, and generally a water bottle is bigger than a paper cup, even a liter is probably going to be too much. So if liter's out, anything's bigger is out, which means kiloliter is out. So really the only thing that makes sense here to say for number 1 is going to be milliliter. So for number 1, we're going to answer milliliter. And then the directions here ask me to justify our answer. So we're going to justify our answer by saying several eyedroppers perhaps you may even want to put in parentheses many eyedroppers. Several eyedroppers would fill a paper cup. All right, let's try one more. Number 2, the mass of a small poodle. So we're talking about mass. We're talking about things that involve grams. So our choices here are milligram, gram, and kilogram. Well, a milligram is the mass of 1 speck of sand. A gram is the mass of a small paper clip. And a kilogram is the mass of a textbook. Now, a milligram would be a very hard way to measure anything unless it's a very, very minuscule amount. Because a milligram, again, is just 1 speck of sand. But I think you could make a good case for grams, which is how much a paperclip weighs. Remember, we're talking about a poodle here. All right, that's a small dog, a very small dog. Or kilograms, you could make a case for. That's the mass of a textbook, about 2-poundish area. Probably a poodle's probably 8-10 pounds. That wouldn't be bad either. So you can make a good case for grams or kilograms here. I'm going to go ahead and say kilograms. And my justification is that a kilogram is approximately the weight of several textbooks. All right, so now I'm prepared to help you with 5, 6, and 7. You're going to do the same thing in the next set of questions as you do in 5, 6, and 7. So if I help you there, you'll probably get enough. Remember, the whole beauty, as you saw in the notes today, the whole beauty of working with the metric system is the metric system, unlike the American system of measures, revolves all around the number 10. It's all about me just taking and sliding a decimal from left to right. But the only way you can do that is if you know the metric prefixes and where they all fill in. So the largest metric unit starts with kilo. And we would append to kilo whatever measure we're talking about, either meter, liter, or grams. So it would either be a kilometer, or a kilogram, or a kiloliter. But that's the largest one, kilo. From there, in descending order, we've got hecto, then deca, D-E-K-A, and I emphasize that because there is another D one. The next one on the list is the actual unit. That's where you would find either just regular old meter, regular old liter, or regular old gram. Heading down towards the small side now, we have deca, D-E-C-I. Again, there was deca to the left, larger than the base unit. Deca is smaller than the base unit. Then you have centa, C-E-N-T-I, and then you have milli, M-I-L-L-I. And all we have to do when we make a conversion is figure out how many jumps I make in the chart and in what direction, and do the same thing with the decimal. For instance, if I was converting from something in decameters to something in decimeters, to go from deca to deci, I go 2 jumps to the right on this chart. And because I take and go 2 jumps to the right, I'm going to take the decimal in my number, whatever that number is totally irrelevant, and take and also move it 2 times to the right. And that will give me the converted numeric solution. So in number 5, where I'm converting from 496 millimeters to centimeters, to go from millimeters to centimeters, I'm going from milli to centa, which is 1 jump to the left on the chart. So all I have to do is take and move my decimal 1 time to the left. And I do that, and I end up with 49.6 centimeters. And that's it. Really easy. In number 6, we've got 0.68 kilograms, and we're converting that to grams. Well, to go from kilograms to grams, that's 1, 2, 3 jumps to the right on my chart. So I'm going to go ahead and move my decimal 3 times to the right. 1, 2, 3 times to the right, and I end up with 680 grams. Finally, in number 7, 3,800 milliliters being converted to liters. So if I look at my chart, I start at milliliters and I go to liters. That's 1, 2, 3 jumps to the left on my chart. So my decimal and my number is also going to make the same move in the same direction. 3 jumps to the left. So I go 1, 2, 3 jumps to the left, and I end up with 3.8 liters.